Are congruent. Basically, what we're going to be doing is we're going to be proving that the sides and the angles between the two triangles are the same. Okay, we're going to go over 4 ways to do this. Well, 4 shortcuts, because there's 4 types of congruence that if we have these, just you end up having 3 parts. So between 2 triangles, I have 1, 2, 3 angles and 1, 2, 3 sides. So I'd have to show 6 things were congruent all the way to if I was showing every single thing. We have some shortcuts where we only have to show 3 things that are congruent. And we have side, 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 angle, side, angle, side, angle, and angle, angle, side. And I'll go over each of these individually. This is side, 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 angle, side, angle, side, angle, and angle, angle, side. If you can show one of these, so you can show all 3 sides are the same, or the 2 sides with the angle in between them, or 2 angles with the side in between them, or 2 angles with the following side. You only have to show 3 things instead of all 6, and you can prove that the triangles are congruent. You will notice we do not have angle side side. Okay, we don't constant geometry class, and also it doesn't hold true. So angle side side really will not prove triangles congruent, and it's convenient because it spells a bad word anyway. So no angle side side, and no flipping that around, so no side side angle either. Okay, so the first one we're going to cover is side 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 congruence. And you have side 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 congruence when all 3 sides Okay, so if we can show that the 3 sides are congruent between 2 triangles, then we know that the triangles themselves are congruent, because the fact that the sides are all the same length is going to actually force the angles to be the same. And they have to be corresponding sides. So I should put that in there. Corresponding. Okay. All right, so usually the way these work is you'll be given a couple things, and then you'll either have to define something or state what the property means, or use a vocabulary word of some form, or maybe reflexive property, something like that, to get to the 3rd thing. Most of the time. You'll be given 2 and you have to use definitions or properties to get to the 3rd. And that's what happens here. We have, we have our statements. We have our reasons. Okay. And we are given that GH is congruent to KJ. And I'm going to label that GH and KJ. Okay, so that's one set of sides. And then we're given that H, that's supposed to be an L. HL is congruent to JL. That's this set, sides. And then L is the midpoint of GK. And this is the key statement right here. L is a midpoint. We're going to have to define this. Because if you're told something like that, if you're told vertical angles, or if you're told bisector, or if you're told midpoint, or anything anything like that, the very next sentence is usually supposed to be, and that means this. And so we're going to say that. Since L is the midpoint of GK, that means that GL is the same length as LK, because that's the definition of midpoint. And that gives us that this part and this part are the same length, and then I have 3 sides. So I can finish this off with my triangles are congruent by side, side, side. All right, we're going to try to decide if these are congruent or not by using side, side, side. And there's 2 ways to do this. And the first way is using the distance formula. And then I'm going to show you another way using graph paper. Okay, and then you can pick and choose which one you like better. So we're going to have triangles D, E, F, and PQR. Okay, and I'm going to use the distance formula. So x1 minus x2 squared plus y1 minus y2 squared. All right, so I'm going to do DE first. And DE is -6 minus 1.
Oh, that's what you, oh, I did the same thing. I just, I wrote it out more. That is, okay.
Got it?
Yeah.
Okay. And then 1 minus 2. So I get -7 squared and -1 squared. So 49 and 1, so square root of 50. And I'm just going to go ahead and label it because it's easier to keep track of that way. And then I have to do PQ because that's the coordinating, so I have to make sure it's the same size. If I continue to find same side lengths, I have to keep going. If I find one that's no longer the correct lengths, then I can stop. So PQ is 0 minus 7 and 5 minus 6. So I get -7 squared and -1 squared. And these match. So if I keep going, I'm going to get the square root of 50. I don't actually have to finish doing the work. I can already tell that they match. So those are good. So then I'm going to try EF and QR. So EF is going to be 1 minus -1. So that's 1 plus 1 squared, and 2 minus -4. So that's going to be 2 squared and 6 squared. So 4 and 36. So 40. And then QR, I have 7 minus 5 and 6 minus 0. 7 minus 5 gives me 2 and 6. These match again. So this is going to be the square root of 40 also. So far so good. And finally the last set, DF. I have -6 minus -1 and 1 minus -4. And so I'm going to get -5 squared plus 5 squared, which is 25 and 25, so 50. And then PR is the final one. And I'm going to get 0 minus 5 squared plus 5 minus 0 squared, which is 5 and 5. So it's also going to be the square root of 50. So yes, they are congruent by side, side, side. Okay, because all three sides are the same. Now we're going to do this exact same problem graphically. All right, so hold on one second. So I'm going to do this exact same problem graphically. So first we need my coordinate plane. So just like that. And then I'm going to do this triangle in red and this triangle in blue. Okay. So D is at negative 6, 1. E is at 1, 2. And F is at negative 1, negative 4. And I'm going to make my triangle. Okay, and then P is at 0, 5, 7, 6, is Q. So that's P, that's Q, and then R is 5, 0. Okay. And so what I'm about to show you, the reason it works is because if you remember right triangle geometry thing, it's a terrible right triangle. Okay, right triangle. This is A, and this is B, and this is C, and A squared plus B squared equals C squared. And if I take the square root of both sides, I get the square root of A squared plus the square root of B squared is equal to C. And this is how we find the distance formula. That's how this was derived. So we can take the triangles that we have and we can draw right triangles off of each of the sides. Okay, we're going to make each of the sides of these triangles our hypotenuse. So I'm going to start with green. I'm going to do DF and PR. So to go from D and F, I'm going to make a right triangle. And then PR kind of already has one. And if the lengths of these legs and these legs are the same, then the hypotenuse, or hypotenuses, I'm not sure which it is, would also be the same length. Does that make sense? Okay, so I'm going to count 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So these are the same lengths, so that makes these the same. So far okay? And then I'll go to the next set of sides, and I'll go from D to E and P to Q. I go up 1 and then over. So go up 1 and over 1, 2, 3, 4, 5, 6. 1, 1, 2, 3, 4, 5, 6. Those are the same. 1 and 6, 1 and 6, so that makes these legs the same. Or those sides the same. And then purple, I do E to F and Q to R. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, and then 1, 2, 1, 2. And that makes these the same. So that's how I can do it too. So you can either do the distance formula or you can draw the triangles and then count the right triangles off of each side. So back to distance formula, DE is D. So -7 minus -4, so +4. And then -3 minus -1, so +1. And I get -3 squared and -2 squared. So that's going to be 9 plus 4, which is the square root of 13. So then I need to do PQ. And I get 2 minus 5 squared plus -2 plus 4 squared. So I get -3 squared plus 2 squared, which gives me the same thing. So square root of 13. So those are cool. Those are the same length. And then if I do EF, I have -4 minus -2, so -4 plus 2. And then -1 plus minus -5, so plus 5. So that's -2 squared plus 4 squared, so that is 4 plus 16, so that's the square root of 20. And then QR is going to give me 5 minus 0 squared plus -4 plus 5. So 5 squared plus 1 squared, which is 25 plus 1, which is the square root of 26. And those didn't match. So as soon as that happens, we are not congruent. To column proof, we have the statements and the reasons. With the flow proof, it's how the flow goes, so you get like arrows and boxes. Okay, so your givens, you still have to write reasons. It's just in boxes. So we have a RS is congruent to TS, and that was given. Okay, and that's already labeled. And then I have I'm looking at the wrong thing. V is the midpoint of RT. And that's given. Okay. And that means that RV is congruent to VT because of definition of midpoint. So far okay? So what I have now is that these two sides are congruent, that was given, and these two sides are congruent from midpoint, and I need 3 sides. And I have that VS is congruent to itself. And that's reflexive. I didn't draw that very well. And all together I get that the triangles are congruent from side, 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 and it's these things that get me there. So that's what a flow proof looks like. to do side angle side congruence, we talk about the included angle, and that's the angle formed by two adjacent sides so that it's in between. So if we're looking at this side and this side, our included angle is right here in between. And so we'd say side angle side. It has to be in between the two sides. And so our side angle side congruence is if two sides and the included angle of one triangle are congruent to the So basically, if two sides in the included angle of one are the same as two sides in the included angle of the other, then the triangles are congruent. Okay, so side angle side. So what we would have is AB. Hold on. AB would be congruent to EF.
It's transparent.
And BC would be congruent to ED, and you would also have to have that angle B and angle E were congruent. So for side angle side, you'll just have to prove the two sides are the same and the angle in the middle is the same if that's not given to you. So a lot of times those are pictures like this. So if we look at this, I have that these sides are the same. That's marked. I know that these angles are the same because of vertical angles, but I don't know anything about the other sides. So I'd have to either have side, 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 or side angle side, but I don't have that. So this one's not possible with my given information. For number 5, I could use two different ways. I could use side, side, side because they share this side right here. But also, because they share that side, and because if this is 90, this is 90, I also have side angle side. Do you see that? Side angle side, where these two 90-degree angles are the angle that they have in common. So this one could be also side angle side. So sometimes you get to the triangles being congruent more than one way. You just see the way that makes sense for you, and then you pick that one. Here, these sides are the same, and then this is the same as itself. So I'm going to have side, side, side. Does that make sense? Okay. To measure the width of the sinkhole on his property, Harmon marked off congruent triangles. And how will he know that this length here and this length here are the same? Well, because these two lengths are the same and these two lengths are the same, and these are vertical angles. So those two are going to be the same. So he'll know that AB and B prime, A prime are the same because the triangles are the same by side, angle, side. And if one part of the triangles, if you have two congruent triangles, if one parts are the same, all of the parts are the same. So that would make these two lengths the same size. So that's how people do things like measure the length of something like a sinkhole that you can't cross it, you can't like climb on it and measure it, right? It's a sinkhole. So you can use this type of measurement. I'm going to use side angle side. I'm given that WZ is the same as YX. So WZ and YX are congruent. Okay. I'm given that WX is parallel to ZY. So these two lines are parallel, so I'm going to put that marking there. And I want to prove that the triangles are congruent. Well, I have a postulate that tells me that the distance between parallel lines is the same all across, right? Hold on a second. Okay, so we have parallel lines, right? And we're looking at trying to prove WXZ is congruent to XYZ, these two triangles. Okay. I know that this length is the same as itself from reflexive property. So I'm going to use that. XZ is congruent to itself because it's reflexive. I forgot to write given. Okay. So I have side and a side, two sides. So I either need the third side or I need the angle. Because these are parallel and this is a transversal, I know that these are congruent. So angle Z is congruent to angle X because of alternate interior angles. And then the triangles are congruent from side angle side. So we had the outside lines, we had to get the inside line and the angles. The inside line was easy because it's just itself. So you just had to remember that these were alternate interior angles of that parallel line.